Okay, gang, so we've been working in section 6.5 and we're talking about applications of exponential functions and in particular exponential growth and decay models now, okay? So we were talking about compound interest if you recall, right? In number 2 of the exercises, what they ask us for, well, first of all, what they told us, we're given a principal amount of $500, an interest rate of 0.75%, and the interest is compounded continuously. What they want to know is, right, well, actually, there's a few things they want to know. So hopefully you've got your book open and you're taking a look at this. But one of the things they want to know is how much is going to be in the account after 5 years. The second thing they want to know is how long is it going to take for the initial investment, $500, to double in size. Now, we talked about these things in the previous video, so that'll give us a good head start on this. Because the interest is compounded continuously, not a finite number of times, but a continuous amount of times. The formula for compound interest that we're going to use, gang, is going to be this. Okay? Now, we just simply drop our numbers into this, right? The principal amount P, that's $500. R, we have to rewrite that as a decimal now, not as a percent. And so we get the following. Okay? Now, to answer their question, find this. Okay, so in other words, how much is in the account after 5 years? All right, well, it's a calculator problem, gang. It's a calculator problem. Okay, everything into the calculator at one time. You don't have to do it piece by piece, right? If you've got a good scientific calculator, you can enter that whole thing in one time. So I worked this out on a separate piece of paper. And this winds up being $519.11. Okay. Now, like I said, the other part of the problem is how long is it going to take for this initial amount to double in size? Well, if you recall, gang, in the previous video, we developed a formula one time for all time that would help us find the doubling time, right? So I'm going to put that up here. Right, the doubling time was the logarithm of 2 divided by k, where k was the growth rate or growth constant. And in this case, what they're referring to is the interest rate of the account. Okay, so in the context of this problem, here's what we've got. Okay, so we'll write it like this. Okay, into the calculator, and that winds up being about 92 years. Okay? All right, in the next example, we'll see what happens when the interest is compounded a finite number of times.